Hi guys, so you're about to do the fourth part of your project. So this is the last part of the project for the class. So these ones, again, solving literal equations, these ones are probably going to be the toughest because this is the fourth part. So just like the other ones, make sure you write down these examples with me and then use those notes when you do your project. I made these problems very similar to the ones that you're going to see on your project. So this will be really helpful for you. All right, so I use the arrow to show which variable we're trying to solve for. So here we're trying to solve for c. All right, so right now I have c is being squared. It's also being multiplied by this 1/3 a. So I'm first going to divide by 1/3 a on both sides. Okay, so over here on the left, when you divide by a fraction, when I'm dividing by 1/3, that's the same thing as multiplying by 3/1, or just 3. So you need to know that for this project because I believe they put it in that's how they write it. So when I'm dividing a divided by 1/3, it actually comes out as 3a. And I'm actually dividing by a also. Maybe I shouldn't have used that variable. I'm going to change this variable to b because I think I shouldn't use the same variable there. Make that adjustment real quick. So I'm dividing here by b. On the right, I canceled out the 1/3 and the b, and I just have c squared. So now to get c by itself, I have c being squared. The opposite of squaring something is square rooting it. So I'm going to put a square root over that. So on the left, I have the square root of 3a over b, and on the right, I just have c, because the squaring and square rooting canceled each other out. Okay, so you'll notice on all of these problems here in this section, we're solving for something that's being squared or has an exponent. So that's kind of the theme of this part of the project. All right, so this one, number 2, I think is the most complicated one out of all because it has c being squared, it's being multiplied by some stuff, and there's addition. So when we're doing these, remember you always do the order of operations backwards. So I need to first do the addition or subtraction step. So I'm going to subtract 1 from both sides. So on the left, I have a minus 1. On the right, I have negative 1/5 bc squared. Okay. So now I'm going to take care of the fact that c is being multiplied by negative 1/5 b. So I'm going to divide by negative 1/5 b on both sides. Now, just like we talked about on problem number 1, when I'm dividing by a fraction, it's the same thing as multiplying by that reciprocal. So this is the same as multiplying by negative 5. So on the top, I'm going to have negative 5 times a minus 1. And on the bottom, I have b. I know that's kind of tricky. Make sure you have these written down in your notes. On the right, I canceled out the negative 1/5 and the b, and I just have c squared. I'm trying to solve for c. So since c is being squared right now, I need to square root both sides. So on the left, I end up with the square root of negative 5a minus 1 over b. And on the right, I just have c. I think this problem is the toughest because it has so many different steps there. But hopefully you wrote that down in your notes. Number 3, this one will seem easy compared to that. I'm trying to solve for c. Right now I have c times b, so I'm going to divide by b on both sides. So on the left I have a over b, and on the right I have c squared. To get c by itself, I have to do the opposite of squaring something, which is to square root it. So on the left I have the square root of a over b, and on the right I have c. Okay, number 4. So I'm trying to solve for b. b is being cubed or has an exponent of 3. So first I'm going to deal with the fact that it's being multiplied by this 2/3 pi. So I'm going to divide by 2/3 pi. So again, I'm dividing by a fraction. It's that tricky thing. That's the same as multiplying by 3/2, multiplying by the reciprocal, like what it looks like when you flip it over. So what I actually have is 3a over 2 pi. I multiplied it by 3 halves. And then I have this a over pi. On the right, those canceled out, and I just had b cubed. So the opposite of cubing something is cube rooting it. So it looks like a square root with a 3 in it. Cube root. So my final answer comes out as the cube root of 3a over 2 pi. And on the right, I just had b. One more. Try to solve for b here. So right now I have b being squared and it's being added to a squared. I'm going to have to deal with that addition first. So I'm going to subtract a squared from both sides. So on the left I have b squared, and on the right I have c squared minus a squared. To get b by itself, I'm going to have to do the square root again because it was being squared. So I end up with b on the left, and on the right I have the square root of c squared minus a squared. There you go. That's your final part of the project.